Hey everybody, today we're going to be talking a little bit more about the segments that we discussed in our previous one. In the first picture, you'll notice that the three blue lines bisect each side of the triangle. And we can tell this because of the tick marks here and here. Now, what that means is that we have created medians here, okay? So you should be recalling these four types of different lines that we can create in triangles from your last lesson. And over here we have that these three lines create a right angle with the side of the triangle. Now they don't bisect, so this would not be a perpendicular bisector. These would in fact be our altitudes. Okay? Alright, so we have talked about medians and altitudes. Now I want you to take a look at this. Now the medians are what we did when we took the triangles made out of cardboard and we drew the medians. We were able to find the center inside of the triangle, and we noticed that that was the center of gravity. Notice how the median, those lines are concurrent inside of the triangle always, no matter if it's right, acute, or obtuse. So when I told you you could cut any triangle you want, I already knew that no matter what kind of triangle you cut, your medians would all meet inside the triangle. Now that's not necessarily the case with the altitudes. If you take a look here, in the altitudes, you'll see that this line right here is an altitude because it meets this side at a right angle. Same with this one. So these two sides are actually the altitudes as well as the sides of this triangle. And then this one right here is a right angle. So the place where the three altitudes are concurrent is actually right here on the corner. And that's going to be on the circle. Alright, now here we have the three altitudes inside of an acute triangle will be concurrent inside of it. Now the obtuse is a little strange, okay? If you take a look at this, as of right now, this altitude, and this altitude are not concurrent at this point. But if we were to continue this and extend it out, so I'm doing a rough estimate here, you'll see that it's actually concurrent on the outside. Okay? So it's going to be very important because on tests and quizzes I may ask you, hey, where are the altitudes concurrent on an acute triangle? And you need to be able to say inside. Or where are the altitudes concurrent on an obtuse triangle? Outside. Sorry guys, I apologize about that. My cat can be a little vocal sometimes. So that was Ben. I apologize. But hey, maybe we'll use it in a pop quiz and we'll see if you guys are paying attention. So, alright, just to clarify the definition of a median, okay, a median goes from one vertex to the opposite side, and it cuts the opposite side in half or bisects it or cuts it into two equal pieces, okay? So that's very important. Now, whenever we have three medians, we already know they're going to intersect inside of the triangle. And we found that out with our triangles that we cut from cardboard, and we found it to be the center of gravity. But that center, that concurrency point, right here, here, and here, it's actually got a name, and we call it the centroid. Okay, so the centroid is where all three medians meet. Now, remember, in our last video, we had medians, altitudes, angle bisectors, and perpendicular bisectors. That means that there are going to be four different types of centers inside of each triangle. It's your job to memorize that the medians are concurrent at a point called the centroid. And that's very important, okay? So you're going to have to memorize the four segments and the four centers that they make and be able to correctly identify which goes with which. So for right now, you only know the centroid made by the medians. Alright, now the special significance about this, now I'm going to move this a little over, there we go. Okay, it says the distance from the vertex to the centroid is 2 times that. So the distance from the vertex to the centroid is going to be 2 times the length of the centroid to the opposite side. Alright, so we can say that BP is twice the length of PF. Alright, so if BP is 6, then doesn't PF have to be 3 because it's going to be half the length of BP? And then BF, I would add it up. So if this is 6, then this is 3. 3 plus 6 is 9. Alright, now PD is 2. So this piece is 2. I need to multiply this by 2 to find AP because the distance from the vertex to the centroid is twice as long as the remaining piece. So that means that AP has to be 4 and AD is 4 plus 2, which is 6. Now on this one it says CE is 12. It says this whole line is 12. So I know the long piece is 2x and the short piece is 1x. So 2x plus x equals 12. So 3x equals 12, x equals 4. So PE is 4, and that means CP must be 8. You can go back and check. 8 plus 4 is 12. Alright, I want you to pause the video and go ahead and try this problem for me, please. Alright, it says P is the centroid of QRS. So that means that this side is cut in half. This side is cut in half here and here, and this side is cut in half here. Okay, that's because a centroid is made by the medians, and the medians cut all 3 sides of the triangle in half. Alright, if PT is 5, then find RT and RP. Well, RP must be 10 because it's twice the length, so that means that RT is 10 plus 5, or 15. Alright, I want you to pause and I want you to try this one. Alright, it says C is the centroid of GHJ, which means this side is cut in half, this side is cut in half, and this side is also cut in half because the centroid is made by the median. So CM is 8, then CH has to be 16. And that means that HM must be 16 plus 8, which is 24. Alright, so let's keep working with the centroid. Pause and try this problem as well. It says T is the centroid of QRS, and TU is 7. So first off, I'm going to make my markings. That reminds me these are the medians. 1, 2, 3, 1, 2, 3. Alright, there we go. So if this is the centroid and TU is 7, and I multiply the small end by 2 to find from the vertex the centroid. So QT is 14, and then QU must be 14 plus 7, which is 21. Alright, so now let's talk about the altitude of a triangle, okay? The altitude of a triangle, remember, is a perpendicular line from one vertex to the opposite side. Now, we talked about the different centers, okay? So let's go back to the beginning page. Right there, okay? Remember, the altitude can be on the triangle, inside the triangle, or outside the triangle, but they were always concurrent. Okay, this point right here, the point of concurrency for each of the triangles has a special name. And it's actually called the orthocenter. So the medians make a centroid, the altitudes make the orthocenter. So there's 2 of the 4 you have to memorize. Okay, so I would not wait until the last minute. I would go ahead and start memorizing these. Making flashcards is one of the best ways. You can keep quizzing yourself over and over and over again. Okay? Now, on this right here, I want to draw the altitudes of all 3. Notice I have a right triangle, I have an acute triangle, and an obtuse triangle. So I'm going to get a line tool out. Let's use this dashed one. How about that? Alright, so let's start with the acute. Okay, from here all the way to the opposite side. Obviously, this is not a right angle. Alright, so I'm going to drag it until what it looks like to be a right angle. That looks close to right. Whoops. There we go. From this one to that side. Let's see, right there looks to be like right, and then here to this side is our right. So that is our orthocenter, and it is inside. So we have inside, and then this is an acute triangle. Okay, so the orthocenter is inside the acute triangle. Now we have obtuse, and I want to do the same thing with the lines, and this time creating, let's see, where's my lines? I need to actually extend the sides of the triangle first. So I'm going to extend this side out, extend this side out. Okay, and then I'm going to go back and get my dashed line. Okay, so from this vertex to this side, you'll notice that there's nowhere I can go that would make a right angle. So in fact, I have to go all the way out here to make a right angle. And when you draw this one, you need to draw it kind of far out. Okay? From this side, there's this angle, I'm sorry, to this side, you'll notice the same thing. I can't make a right angle. So I'm going to have to go out here and make my right angle of sorts. There we go. And then for this last one, from here to this side. So we actually need to continue this all the way out to here. So now we have a point of concurrency out here outside of the triangle. So that would mean that in an obtuse triangle, the orthocenter is outside. Now on the right triangle, I'm going to get a colored line here. Okay, if this is a right triangle, we know this has a right angle, correct? So this line is an altitude from this vertex to the opposite side. From this vertex to this side, that's your right angle. And then from here to somewhere like right there is your other altitude. So where they're concurrent is actually on the triangle. And this is a right triangle. Alright. So now you know how the centroid had a fun fact, and we were, doing some math with it, going back over to these problems right here. Well, the problem with the orthocenter is that currently there's not any known mathematical application. There's no mathematical application for the orthocenter as of yet. Who knows? Maybe one of you guys will figure it out, and then you'll be teaching me something. So orthocenter is made by the altitudes. That's really all you need to know for this one. Okay, so just as a refresher, okay, orthocenter is inside the acute triangle, on the right triangle, and outside of the obtuse triangle. Okay, so let's extend that out so you can see this. Alright, well that's it for the centroid and orthocenter. Tomorrow we'll be talking about the perpendicular bisectors and the angle bisectors and what centers do they make. Okay, so the perpendicular bisectors and angle bisectors are concurrent as well, and they have a special name for where they're concurrent. So stay tuned for tomorrow, and I will see you guys later.